Oh my God, it's exciting. All right, let's see what we got going here. I gotta set this up so I can see all two of you that have your cameras on. You're very bad people, the rest of you. Allie and Audrey get extra credit this week because they're wonderful. And you, the rest of you all are like booger heads. Okay. And that just went on my recording. So that's going to go out to the internet. So what do you know? All right. So last week we worked with volume. We worked with how do we find what's inside of a three-dimensional shape, right? Now, this week we're going to find out how big the outside is. Now, see, I told you about 2 minutes. Wasn't it about 2 minutes? Still have one more to show up. So, someone left. See how they are. So when we look at an object like this, let's start with something that is a cube. Okay. Now, when we talk about the outside of a three-dimensional object, especially one that is angular like this, we call this a face of the cube. We don't call it a side because the lines are the sides, okay? But the other is the face, so it's a face of the cube. Now, if I'm going to draw this out, if I opened up that cube, it would look like this. Think about it for a minute. Think about it. If you cut that cube open, would it look like this? There's 6 faces of a cube. And if I were to cut the sides, 3 of the lines for each top and bottom, and then cut one spot on the middle part, it would roll out into a shape that looked like this. Now, these are called nets, and you probably did some of these last year, I would bet. So in this situation, because this is a cube, I know that every last line here has a measurement of 5, don't I? Because that's the nature of what a cube is. Now, if I look at this one, this little object down here, and I see this is 5 by 5, and that means this is 25, right? That's going to have an area of 25. Well, there's 6 of these squares, so 6 times 25 is going to be 150. Now I'm going to make this inches so I can say inches squared, because remember, now we're back to area. We're not talking about three-dimensional space. Now we're talking about surface. We're talking about surface area. So we have to drop back to the number 2 for our little exponent above the units, right? Because now we're really only dealing with 2 dimensions, which is length and width. But we're dealing with a lot of them, all right? So that's a basic idea of what surface area encompasses, right? Now, life gets kind of interesting when you start working with a rectangular form. So if I have an object that looks like this, I'm going to have to put out a little bit of effort to understand how big each face of this object is, right? Now, one of the easiest ones to see, first of all, here's my height of 6. So I'm going to transfer that height around so that I can use it other places. Now you see how I'm doing it to its opposite places, but I'm keeping it where it's supposed to, doing it in the right spot. So if you look at this end right here is going to be 5 by 6, isn't it? Right here. So I'm going to write 5 by 6. How many of those faces are there? They're the same size. There's 2, right? Because the other side of the box is going to be identical, right? So I'm going to say that we're going to have 2 of those. Now, this front side here, or let's go from the top. this top part is going to be 5 by 10, right? Do we see that that's going to be 5 by 10? So 5 by 10. And there's two of those as well, right? The top and the bottom. Now the front of this box is 6 by 10. And there's two of those. So now we have basically created the building blocks for making a formula for finding the surface area of any square or rectangular prism. Okay, so, but if I want a formula, I have to generalize it, don't I? I have to make it so that it's not a specific number, but I'm using variables, right? So I'm going to use A, B, and C. Now, A, B, and C. Now I'm going to assign these letters to each of these numbers and see what I can do to write a formula that I can use on any problem that I want to. Because it's great that I figured this one out, but I'd like to have a way that I can do it that'll be easier, faster, less of a pain in the butt. Yeah, okay. So here I have A times B, right? Because A, 5 times 6, A times B, right? And then I have A times C, right? A times C, right? So I'm going to say, and then finally, I have 6 times 10, which is B times C. So now I have taken my specific example where I had specific numbers, and now I've converted it into a formula that can now facilitate any number I want. Okay. Now, so let me get our worksheet out here. So our worksheet, I don't want to start with one of these. I want to start with number 6. Let's get that a little cleared up there. So if I look at number 6, I can actually come right on here and label those 3 dimensions like that. Isn't that pretty easy for me to do right away? And then I can immediately plug that into my little formula that I made, right? So I can say 2 times A times B. Wow, that's funny. It's almost the exact same dimensions of the one I made up out of my head. Okay, that's freaky. A times B would be 5 times 6, right? And then A times C would be 5 times 11. And then B times C would be 6 times 11. Now, all of these are simply just things that I'm taking this little formula where it takes into account all of the faces of that object. It takes into account that there's 2 of each and then adds them together. So, okay, we have a comment. Yeah, let me show you. So 5 times 6 is 30, times 2 is 60. 5 times 11 is 55, times 2 is 110. 6 times 11 is 66, times 2 is going to be 122, right? And I'm going to add these up, and I get 292, and I'm hoping that's the right answer. Did I do something right? 6. What? I must have added it wrong. 66. Oh, it's 132. My bad. Sorry, I multiplied wrong. Oops. And so I get 302. Now, in this case, it's meters, so I would say meters squared then, right? Make sense? Give me a thumbs up if that makes sense to you so that I know that you're out there and alive. All right, thank you, thank you. All right, almost everyone so far. 2 more people. Come on, Liliana and Brian. Does that make sense? Somebody just has to use the chat. It's probably Liliana. Yeah, see how she is? Do the letters go to a certain side? No, it doesn't matter because there's still the same number of pairs and there's still, no matter what order you put those letters in, it's still going to give you the same 3 unique pairs of faces, which I love because you can't screw up on that. You can't pick the wrong one. Now, if we look at a problem like this one here, number 1, you can see that we have a 9 and 2 10s, right? I'm going to zoom in on this just a little bit. So now I would have to have an A is 9, B is 10, C is 10, right? And then I'd have to do my work with that. Make sense? Questions? It's really simple stuff. I mean, it's not hard. You know, you just have to get the main concept across, and then it's like, oh, well, that's a piece of cake. Yeah. Now, cylinders. Cylinders are really weird. Because here we are with the cylinder. And I want to know what the surface area of that is. Okay. Well, the top and the bottom are pretty easy, right? I mean, that's just going to be 2 times pi r squared. I mean, I can do that. That's not a problem. What am I going to do with this side? It's not a face, right? Because it's not angular. So it's the whole middle part. What am I going to do to find out the dimensions of that thing? And what does it look like? What does the net look like for this? If I were to blow this object up like I did with my cube, right? What would this thing look like? Let's think about it for a minute. What would this look like if you were to cut it apart so that you could lay it flat? Because when we do that, we'll be able to get a better sense of what that side part is going to be, what the dimensions of that are. So we know we're going to have 2 circles, right? But this is the thing that's kind of weird, right? What are we going to do with that? Somebody has an idea. Oh, yes, Mr. Wen. You are correct. Good, Audrey. Nice. Yeah, you know what this thing's going to be? It's going to be a rectangle. So think about it. If you have a soda can and you cut the top and the bottom off, and then you cut a line down the side and you open it up, it'd be a rectangle, wouldn't it? Now, we don't think of something round being something rectangular. But if we lay it flat, it's just going to be a rectangular piece of aluminum then, right? Now, let's draw this one more time a little bit better. Thank you. Looks like the beginnings of a Flintstone car or something. Yeah, very similar to that idea. Yeah, exactly. So I know what this is because that's my height, right? I mean, I already knew that because like up here, this was going to tell me it was 5 and this was 10, right? Because I have to have that. What is this dimension going to be though? Because I can't find out what this is until I can find out what this line is, right? How am I possibly going to find that out? Think about think about how this thing goes back together and what touches every piece of this line here. Think about it for a minute. See if you can figure it out. Sorry, I'm asking you to actually think. Yeah, the tops are the same. Or are you saying it's the same as the tops, Audrey? Yeah, it wraps around the tops, right? So if this wraps around the tops, then this circle is going to be the same as this line, isn't it? Think about it a minute. Does that make sense? Because when it's all put together, the circumference of that circle is the same as the long portion of that rectangle, isn't it? Because they're directly connected. So what we're going to look at here is we need to know what the circumference of that circle is. Well, remember that the circumference of a circle is pi times the diameter. So I think you can see already that once again on this one, our answer is going to be in the form of pi, right? We're going to have some answer that's like 600 pi, right? It's not going to be, it's not going to be a number in that respect. It's going to be a value that is represented in terms of pi. So our diameter is always going to be twice the radius, right? So r equals 1/2 d, and d equals 2r. So if r is 5, 2 times r is d, the circumference is going to be 10 pi. Now, if I look up at the top of this, at the top here, I know that my height is 10. So I'm going to have to multiply this by 10 again to get this area here. Okay, so that's the circumference, and then the area of the side is going to be 10 pi times 10, which is going to be 100 pi, because the area equals the circumference times the height. So take a look at that for a minute and see if that makes sense to you. I know I wrote a bit right there, so I'm going to shut up for a minute, or at least stop writing. Can't promise I'm going to shut up. Does that make sense? Do you see how that works? So now I've discovered what this area is, because it's 2 times the radius. Aha, very good question. We're going to add it up to this stuff here, right? Because these are the tops, right? The 2 pi r square is the area of the tops. So the surface area of a cylinder is going to be equal to 2 pi r squared plus pi times the diameter times the height. So look at that for a minute. Here's our circles, no big deal, right? We knew that right out the door. But then we're going to multiply the circumference times the height. And to do that, we're going to need the diameter. And this is how we're going to find the area of a cylinder. So here's our formula, right? Now we have a formula again. Now, if you prefer, you could use pi 2r times h if you want, because if you don't like using the diameter and you're like, I don't want to switch units, I just want to keep my radius, then you can do that as well, because 2r is equal to d, right? So if you prefer this, do that. It doesn't matter. You're going to have to get the radius for the circles anyway, right? So if you don't want to mess around with the diameter, you can just think of it in this way, and that works as well. So let's look at one of the ones on the homework. So let's look at this one right here, number 24. So I've got a height of 8 and I've got a radius of 3. So I'm gonna write out my equation first, and then I'm gonna plug my numbers into it. So there's my formula, and I'm going to set for a minute while you're writing feverishly, those of you that are taking notes feverishly. See how that looks to you. Does that look right so far? Okay. Joseph says, yep. I got the 6 because it's 2 times r, and the r was 3, so I just multiplied that because it was an easy enough thing to do. I just did it. Okay. So now if I come down here, I'm going to have 48 pi, and 3 squared is 9 times 2 is 18. So when I add these all together, I'm going to get 66 pi centimeters squared, right? Because it's not going to be cubed, because we're not doing volume anymore. We are doing surface area. And yes, we're going to do at least one more. For those of you at home that are like, ah! Oh, I forgot about the triangle ones. Okay, we're gonna have to go back and do one of the triangle ones too. Does that make sense with the cylinders? Do you want me to do another one? Anyone? Okay, I'll do one more. Okay, let's look at number 21 here. He said, let's see. 21, my height is 5, my radius is 6, right? Because I have to cut that diameter in half. I'm going to write my formula. I put the 2 in front this time just because it makes me feel better when it's in front, because it doesn't look right in the middle of it all. But it doesn't change the math at all. Now I need to plug my numbers in. 2 pi r squared okay. Now I didn't double the radius this time. I just kept it at the radius, kept that 2 in front. What is 5 squared? That's going to be 25 times 2 is going to be 50 pi plus 6 times 5 is 30 times 2 is 60 pi. So my answer is going to be 110 pi yards square. Yeah. Not tough stuff by any means. Again, just a matter of teaching the concepts of how we can break apart a 3-dimensional object, right? And that's really one of the main points of this subject, is to see 3-dimensional objects more than just a block of something, but realize that there's an outside to them that you can graph out and measure and quantify. Yeah. Now, I put 5 problems in here for a triangular prisms. Now, this shouldn't be that much more difficult, right? We just need to remember that the area of a triangle equals base times the height divided by 2. Now, on a triangular prism, there are 5 faces, right? There's 5 faces. I've got the 2 triangles, and then they make a rectangle on each side because of how they fit together, right? So I have to be more, this takes a little more determined thought because it's not going to be the same everywhere. So I have to be more careful when I do this. Now, I'm going to draw a picture of the triangle so that I can see it clearly in my head, okay? So I can understand how it looks more, okay? So it's 6, 8, and 10. So this is what the triangle looks like. Now, the height of this prism is 3, yes? Now, I'm going to do my old-fashioned, my little A, B, and C. Now, I want you to look at what I'm doing here, and as I'm writing this formula up, I want you to think about it in terms of, does this make sense or does it not? Oh, I forgot to put the right angle thing here because that's important. Now, for the purposes of the triangles, I'm going to call the height of the triangle height equals 8, and the triangle base equals 6. So I'm gonna pick which 2 dimensions I'm going to use to find the area of the triangle, okay? Because that's important. I can't just use any 2 numbers. I have to use numbers that I can represent easily as a height. The 10 is the hypotenuse, so I can't use that one in calculation of the area of that triangle. So I do have to be careful with that, right? So that'll take care of the triangles. I'll take care of those in a minute. But I'm really worried about these sides. So I'm going to think about these sides. So I know that every side, I'm going to have to, every face that's rectangular, I'm going to have to multiply by 3, won't I? Because 3 is the height. Think about that. Does that make sense? Because this is 3, this is 3, and this is 3. So this is 6 times 3, this is 10 times 3, and this is 8 times 3, right? For each of those side rectangles. So watch this. Well, because 6, 8, and 10 are the dimensions of the triangle, right? So that's the base. So the 3 has to be the height of the actual prism. Because if you kind of turn it on its side, you're going to see that you've got an object that is 3 inches high, or whatever it is, 3 meters high, and then the base of it has 6, 8, and 10 as the sides of that triangle. So kind of move that object around in your head and see how you can rotate that thing so that the 3 is facing you directly instead of kind of off to the side. But wouldn't this give me the measurement of those side rectangles? Think about it for a minute, wouldn't it? Because it's 3 times A plus 3 times B plus 3 times C, isn't it? A, B, and C, right? Okay, now let's go back to a piece of paper because it is more involved. I mean, I don't mess around with the stuff. If something's a little more complicated, I tell you straight up, don't I? That this is going to be a little more complex. We got to pay attention a little closer, but it really shouldn't be too hard. So first of all, I'm going to bring these rectangles down, and I'm going to put in the real numbers for A, B, and C. Okay. And I'm going to have to add these to the areas of the triangles, right? Now, so these are the faces and the bases. Faces and bases. I just made that up. Oh, yeah, I know. I got issues. Well, here's my triangle, right? 6, 8, and 10, and it's a right triangle. which means that either 6 or 8 could be the height. Now I decided up here that this was going to be the base and this was going to be the height. Okay, so I'm going to do 6 times 8 divided by 2, and that's going to be the area of one of the two triangles, right? But I have 2, so I'm going to have 2 of these. What does that 2 do at this point when I multiply that by 2? What's that 2 on the outside going to do to anything, Audrey? Yeah, it's going to get, ooh, she used math vocabulary. She said it's going to get rid of the divisor. She's like so impressive. Ooh. It's going to get rid of those 2, isn't it? And what I'm left with is 48, which is basically the 2 triangles, right? So I'm going to put 48 up here. Now, 6 plus 8 is 14, plus 10 is 24. 24 times 3 is 72. So 72 plus 48 is 120. Now I need to go look to find out what the answer to number 17 is. God, I hope I'm right. Look. Yay, we got it right. Yay. Clap. Yay. The math fairies in the universe are very happy because we have successfully calculated the area or the surface area of a triangular prism. Now, you are probably going to have to watch the video while you do those other 4 because that's kind of hinky. But do you see how I broke it up? Are you able to see how that works, how that triangular prism breaks up? Because here's what, let's see if I can do this. Crap and a half. Can I do this? So if this is a height of 4, I know it's a little lopsided, but that's the first time I've drawn one of these and God only knows how long. So you can see how this is going to be the height, because if I took this object and I turned it on its side, you can see how the triangles are above and below that 4, right? So that means that when you look at it straight on, it might look like this, where this is like this line right here. See that? Does that help you see that height, Allie? So this really dark line is this really dark line here. And so when you turn that thing on its side, it's going to look like this, where here's one arm of the triangle, here's the other side, here's another arm of the triangle here. Does that help you kind of visualize that in your head to see those 3 dimensions now? Okay. All right. So it has been requested that I do one more of these and preferably shut my mouth during most of it this time instead of talking so dang much. I don't know who would have said that, Allie, but you know, there's a lot of rude people, Allie, in the room. So sometimes Allie has to always put her oar in, Allie, and say something, Allie. All right. Let's do number 20. So as I'm looking at number 20, oh, you're fine. As I look at number 20, I want to determine what is triangle and what is height. So here's triangle, and the stuff I haven't drawn is going to have to be the height, right? So 12 is going to be my height for the whole object, right? It'd be really good if this was on the screen. Wouldn't it be great if I did that? Isn't that awesome how you know I did that? So yeah, let's do that again in slow-mo replay. I drew where the triangles were, and what was left over that hadn't been drawn on would have been the height of the So we're going to say this is the height of the prism is going to be 12 feet. So, we're trying to find the information that we need to solve this, right? Once we have the information, now we can solve it. So the triangle looks like this. That's not a good drawing. So I have, oh, it's the same one as before. Same exact triangle from before. See, here's our right angle here. Okay, so this is our thing. So I can make 8 the height, or I can make 6 the height. It doesn't matter, right? Now, we're going to do our height here is 12, right? So I'm going to take 12 times these 3 sides added together. That will give me the rectangles that are on the side of the faces that are on the side of this rectangular prism. Because if you look up here, you'll see that like this rectangle right here is going to be 12 times 10. Well, there's 12 times 10. This one back here is going to be 12 times 8. Well, there's 12 times 8. And then finally, the bottom one here is going to be 12 by 6. So that takes care of each of my rectangles. Now I need to figure out how big this is. Now I remember from before that since there were 2 of them, I didn't actually have to divide it by 2, right? That 2 went away. So I can basically just take 6 times 8, right? Because that's the base and height. And I'm going to just add 48 right out the bat because I don't have to think about that. I can just realize that since it's a triangular prism, I'm just going to do the base and height of the triangle times each other, and that will give me the area of both triangles. So this is the area of the triangles. And this is going to be the area of the rectangles. Does that help that I just wrote that there? Does that make it a little clearer? Maybe? Oh, you guys are just so smart. You don't need it. So now let's go ahead and calculate. Oh, at least somebody out there appreciates me. That's nice. Thank you, Liliana. So now I'm going to have 6 plus 8 plus 10. That's going to be 24. So I'm going to have 12 times 24 plus 48. Okay, so I've got to do 12 times 24. And then, so I got 336. Let's see if that's the answer. What was that, number 20? Number 20. Oh, we got it right. Look at it right there. Ah, ah, ah. We're so smart. We got it right again. So it comes up to be 336 feet squared. Put that back into view. Now, do you have any questions about any of these, any of the surface area things for these problems? Does it make sense? No questions? Good. Okay, so give me a thumbs up at this point if you feel like, yeah, this makes sense. I can do this. Okay, that is very good. Let me go ahead and stop this recording because